Okay, so. Everybody's doing okay with this, everybody has the first one, okay? So if my B. Sorry, if my A. And Brandon, I might have told you something wrong there. If my A. My function is f of x equals x minus 5 squared, right? Okay. So if I got f of b, well, in my case, that would be f of 7. Okay. And what's f of 7? Well, I've got f of x equals this, x is now 7. So it's going to be 7 minus 5 squared, right? So that's going to be. Now there's more I can do with that. 7 minus 5 is 2, square that, you get 4. Don't need to do it, but if you're doing it, oh, you're doing it quickly, it's okay. F of negative c. That would be f of negative 9. X is then negative 9, so x has to be negative 9. That's going to be negative 9 minus 5 squared. Okay. Now, if you leave yourself room off to the right, I didn't squeeze this stuff in. You got room to simplify them, but you can do that later. Unless you do it quick. Okay, what's f of 2 cubed plus d? That's in my case. D is not D is 12. 2 cubed is 8. So that's f of 20. And now I can put it in, it's 20 minus 5 squared. Okay. When I get down to f of aardvark, that's one step, that's just aardvark minus 5 quantity squared. Okay. So you just do a direct substitution. You do one step on each of these. In other words, once you get whatever that is, once you've replaced x by whatever is in the parentheses, you're not done, but you're done with what I want you to do right now, okay? And then we'll see where we go with that. Okay. So we want to, people have done pretty well down to f of x plus h, and a lot of people have done well when they got to x plus h. But eventually, most people are starting to read things in, especially when we get here. Okay. So if you didn't read things in, that's really good. If you did, a lot of confidence. Okay, so don't feel too bad. But f of x plus h. The only question, absolutely only question is what's in parentheses. It replaces by whatever's in parentheses. So if this now appears as x plus h, then that means x gets replaced by x plus h. And here's x. It gets replaced by x plus h. It's that simple. So this equals, I think, let's just write down what x is, just for reference. F of x equals, in my case, x minus 5 squared. We've got a different number there. That's all there is. Okay, now x has been replaced by x plus h. So we have to replace this x by x plus h. So wherever this x is, you just write down an x plus h. And then the minus 5 is still there. Okay. Oh. X is replaced by x plus h. X is been replaced by x plus h. Okay. It's that simple. If you make anything more out of it, you're making a big mistake. Now, there's things you gotta do to square that. Use the distributive law, but we're not worrying about that yet. Okay, we're just worrying about what the function notation tells you to do. Okay, so now we get down to f of x plus h. Minus f of x. Okay, now this is really important, maybe one of the most important expressions in all mathematics. It's the rise of your graph from 2 points, but that's coming up, okay? What's f of x plus h? That f of x there doesn't interfere at all with what f of x plus h is. F of x plus h was x plus h minus 5 quantity squared, and it still is. Nothing else goes in there. This equals okay, because that's what f of x plus h is. So f of x plus h equals this. So f of x plus h still equals this. It doesn't equal anything else just because you got something out here. Okay, nothing else. Okay, that makes sense? That's what it means.
So
Okay.
that,
Okay, so again. Little confusing, still wanting to do something with that f of x. You gotta do something with that f of x, but it's not gonna affect this. When we simplify it, it's gonna combine with it in some way, but that's down the road. We're just looking at one step of substitution. Okay, so what's f of x? Well, I claim that f of x is x minus 5 quantity squared, because that's what it's defined to be, right? That's f of x. F of x equals this equals f of x. Okay? So we have to understand that. One of the two things it's hardest to understand about this. Okay, so really give that some thought. Okay, well then we get down to f of x plus h. Minus f of x over h. Now that h doesn't go in here, it doesn't go in here. F of x plus h minus f of x is just I wrote that too small. Let me read that. Trying to conserve board space. I'm gonna go too far with that. Okay, this equals I mean, you already have f of x plus h minus f of x here. So you just write this down. That's your numerator. This h here, it's going to do things when you expand these squares and stuff, but that's important to do it, but not yet. Okay. Now, this is supposed to actually be a Q here. You might have read it as a G. But what's f of Q? Well, you're replacing x by Q, so it's got to be Q minus 5 squared. F of s plus t replaces x. That's s plus t minus 5 quantity squared, okay? The f of r minus p is r minus p minus 5 squared getting a little monotonous. F of two T is two T minus five quantity squared. Okay. Now what's F of G? Couple people wanted to put their G number in here, and that, no. There's a backward apostrophes around this B and the C, so you do use your A, B, C, D, F, G numbers, right? There's no backward apostrophe here. That's a G. That's a letter G. Doesn't stand for any number. Okay. It's actually going to stand for another function. So F of G. Yeah. Okay, it's a G minus five squared, just the same as F of Q is Q minus five squared, okay? G just behaves like a letter. What about F of G of H? Well, you've replaced X by G of H, so this is G of H minus five quantity squared, right? Okay. Now there's a backward apostrophe around this A. In my case, that's five, right? So we have H of five, right? H parentheses five. Just want to read the symbol. That's H of five minus five squared. And this five doesn't do anything to this five. This five goes into the H function when we finally get an H function. Okay. And then F of G of X plus two H of X. Okay. We have a rule for F. And that says that F of G of X has to be my number is G of X minus five squared. And we don't know anything about the H function. So we can't write anything but just what we already have, two H of X. Now I rewrote the thing I just erased, so I'd have room to do this. But if we just translate this literally, X has now been replaced by this whole P parenthesis Q parenthesis R parenthesis F, close of parentheses, right? So this is whatever this means, that's what we've got. Three parentheses on the left, three on the right, okay. So this whole mess just replaces X, and there we have it. Okay. So I hope we see this. If you're not totally clear on it, go back over whatever part of the video addresses what you don't understand. If you don't understand this, look at it again, think about it, make sure you understand. If you don't, ask me. Okay. All right. Now we're going to look at some of these. You see, in problem 2, I asked you to simplify each of the expressions. Okay. I'll simplify a couple of them. The ones I'm really interested in simplifying are the ones that involve G of H and H of A and all that stuff. Okay. So simplify. I want to simplify F of Q. Well, let's say F of X plus H. Okay, so colors here. Okay, so again, we have F equals X plus H minus 5 quantity squared, right? Okay, now I want to simplify that. Well, that's x plus h minus 5 times x plus h minus 5. Now, how do we simplify that? We use the distributive law. Okay, this is x times all this plus h times all this minus 5 times all this. Okay, so this equals this again. First thing here times whatever's in parentheses, and then the second thing times everything in parentheses, and then the third thing times everything in parentheses. The third thing times everything in parentheses, right? Well, that's x times x. Plus x times h, because x multiplies every one of these things. Plus x times negative 5. Plus h times x plus h times h. H times x here, h times h here, and h times negative 5 here. And then minus 5 times x minus 5 times h minus 5 times negative 5. Okay. Now you can do more with it, but there's your distributive law. Things you can do. You've got an x times h here, right? And an h times x here. Well, x times h is the same as h times x because you can multiply in either order. So you got two x times h's. H times h is h squared, so you're going to have an h squared. You got negative 5 times x and another negative 5 times x. You actually get negative 10 times x. You got negative 5 times h. And here you got negative 5 times h. It's negative 10 times h. So we could go on and simplify this. I want to show you the distributive law stuff. The rest of it's actually fairly simple. Okay. And it's simple. And it's basically algebra 1. So you've got that. So you see the simplification can get a little involved. Not too bad. You got to do it step by step and carefully. Okay. If we get to this expression here, the f of x plus h minus f of x, well, then we're going to have to subtract the square of x minus 5. So we're going to have to multiply that out. And then we have some more terms, some which might kind of cancel some of these terms. And we go on with, okay, well, you can do that. Okay. One more example, a simpler example. And well, q minus 5 squared is q minus 5 times q minus 5. And that's what? Q times q minus 5 minus 5 times q minus 5. Q times this minus 5 times this. And when we multiply that out, we get q times q, which I'll just write as q squared, minus 5 times q. As q times minus 5 is minus 5 times q. Here's minus 5 times q. And -5 times -5 is plus 25. And you end up with q squared minus 10 q plus 25. So if you don't totally understand that, you want to look at it again. Okay, something you need to know. Basically, when you come into the course, if you didn't know it when you came into the course, you need to know it now. Okay, this is a little more complicated, but it's the same idea, distributive law. I finished this one, I haven't finished this one, but I'm out of board space and I don't want to get into all the details, because that's not the primary thing that we're trying to do. What you need to understand is that these things do simplify. And now I want to get to simplifying these stuff. Okay. So now I give you, if you look on the sheet, I'll tell you that g of x is 1 over x. H of x is the square root of x. And r of x equals your a number over x, because it's got backward apostrophes on it. And q of x is x plus 5. Now that I know all of that, I could simplify this p of q of r of s. Okay. I'm probably not going to get to that. I'm probably going to leave it to you to think a little bit about it. And maybe after you've done the homework on composite function. So let's simplify f of g of h, which is g of h minus 5 quantity squared. Can you write out what that would be, since I've now given you a formula for the g function? Okay, so first we obtain f of g of h equals g of h minus 5 quantity squared, right? Now what's g of h? Well, g of x is 1 over x. So what's g of h? It's 1 over h. Okay. G of h, here's your formula for g of x. X has been replaced by h. This is the rule that tells you what to do with whatever's in parentheses here. If you put it under 1. So h is in parentheses, x is replaced by h. Replace this x by h. And this is 1 over h minus 5 squared. Okay. Now, some of you then said, well, h of x is the square root of x, so I can replace h by the square root of x, right? Well, it's not an h of x down here, so technically you can't, but that was a really good thought. Okay. If I wanted to do, and we didn't get it, it doesn't come out of that. But if we did, f of g of h of x, we get, well, g of h of x, well, it's the g of h of x minus 5 squared. And that would be 1 over h of x minus 5 squared. Instead of 1 over h, we'd have 1 over h of x, right? And h of x is the square root of x. we have this. Now, we could still use a distributive law and expand that, that's fine. It's just simple algebra, but algebra you probably need to practice. Okay, we could do this, but we didn't ask this. We asked this, not this, right? But if we'd asked this, that would have been what we'd want to do, so it's good to see this. But I'm just going to kind of lightly cross that out because that's not what we were asking. It's good, because I might have asked that, and if I had, it would have been perfect. Okay, and that shows good insight. So if you did that, that's good. Understand that it's not quite what, not exactly what we asked. Okay. Well, I'm not going to do the rest of these examples, because I'm going to ask you to work through these. Okay. And these are composite functions. So now I'm going to switch gears a little bit. I'm going to ask you this. F of g of x is 2 to the x squared. Boy, gee, what happened to that screen? Totally blurry. I mean, you can't read a thing. I wasn't doing that before. Still doing it. Okay, I think it's. Again. Actually, I don't want to. I'll ask that one later. Now, the F and G and H and everything aren't what they were before. This is new slate. It's totally new F and G functions. Oh, how does it see? I'm going to put it this way. If f of x equals x squared, then what's g of x? Okay, but most are a little bit slower. This is new. I'm trying to think of it. Okay, well, I'm going to tell you that first thing you can see is if you know what your f of x function is, you can plug your g of x function in. F of x is x squared, then f of g of x is g of x squared, right? That's just straight substitution. Okay. Now, if f of g of x equals x minus 2 squared, and f of g of x equals g of x squared, then what's g of x? Well, if this equals this, write down what g of x has to be. f of g of x equals this, f of g of x equals this, so this has to equal this, right? No, g of x squared equals x minus 2 squared. It's g of x. X minus 2. Isn't that kind of obvious? If what you're squaring equals x minus 2 squared. Sorry. What you're squaring here is g of x. What you're squaring here is x minus 2. These two are equal, then what you're squaring has to be x minus 2. Okay, well, that's maybe not the best way for you to see this, so I got that. Talk about it. Okay. Okay, so I just asked a question. Okay, if I have evaluate x minus 2 squared, that's kind of fleshed out. I'm gonna rewrite it. You subtract 2. Then square 10, you get 100, right? So the rule says order of operations, subtract 2 from x. Then square the result, right? Okay. So this says, so we square x minus 2. We could say we square the x minus 2 function, and you know, I said that. Looking out, trying to find the light in your eyes, it's not there yet. Okay, so say it. If g of x equals x minus 2, then we got to square g of x, right? So we start with g of x equals x minus 2, and then we square. Well, the squaring function is x squared. It's the last thing we do, right? What's the first thing we do when we do f of g of x? First thing we do is g of x, right? The first thing we do is we subtract 2 from x. So g of x has to be our x minus 2, first thing we do, okay? And then we got to square it, so the next thing we do is we square whatever g of x is. We square the x minus 2. Right out. Details of the g of x equals g of x squared, which equals x minus 2 squared. Let's say we have another function. Let's say f of g of x is a square root of 2 to the x. What's the first thing that happens to x? It's 2 to the x. Well, the first thing that happens to x here is we apply g to it, right? So the first thing is g of x. The first thing is 2 to the x, first thing is g to the x, so g to the x is the first thing, which is 2 to the x. Okay. Then we find the square root. So f of x equals square root of x. Then f of g of x is a square root of g of x. And g of x is 2 to the x. So that's a square root of 2 to the x. Okay. So I guess what I'm telling you, the thing that I see is starting to make some sense. Everybody, if we just look at the first thing that we do with x, that tells you what the review of x function is. And then if we look at what we do with that, that tells you what your f of x function is. Okay. So let's just. Okay, well, we're out of time. If you need to leave, just go through the back. Want to stick around just for a minute and let me look at what you're doing? You can do that. But, okay, so how about this? What's the first thing we do to x? And then what do we do to that? I would say the first thing you do to x is you put it into 3x plus 6. Okay. Now you could do just 3x. Okay. I'm going to say, okay. So you'd let g of x be 3x plus 6. That'd be easy to calculate. Well, then you got to do its reciprocal, right? Then if f of x is 1 over x, f of g of x would be 1 over g of x, which would be 1 over 3x plus 6. Now, hopefully you see that. I'm going to have to go into my next class now.